Everybody, today I'm gonna show you guys how we can manually edit or modify the hex packet or craft the network packet to specifically send some network transmission over, or overall how we can understand how it works. So the first part of what I will show is actually how we will analyze the Wireshark network packet in the Wireshark tool. And in the second part I will we will make a explanation, or let's say I will explain more specifically about how the hex code works in the network packet layer inside Wireshark. And the third part will be where I will explain the protocols more specifically as how they work, and overall I will show many different kind of clips and videos how we can also then at the fourth part modify and manipulate it. So I will give you guys a brief introduction and packet analysis of the hex data of some of these packets. For example, the ICMP version 6 protocol. If you guys will click on this one, you can see that it shows the frame as the whole packet. So if we go around here, for example, it won't show any hex data specifically, but let's see, for example, on the Ethernet one, we can see this part here. Again, please look on the right side. As we can see, this part of the hex code describes this MAC address basically. And if we will go to the address here, more down, we can see that that LG bit globally unique address describes this part, and also this one describes this other part, the MAC address. So by seeing all this, we can always see which specific information or type of the packet header is actually associated with the hex data here, which can also be modified if you send it over, right? Same with Internet Protocol version 6, which is IPv6. If we go, for example, here we can see the version 6 is 60 is hex data, and here it is this traffic class is 60.00000. We go here, it shows differently here. It's only the zeros. As the payload length is the 0058. The next header is 3A, as you guys can see here. The hop limit FF, source address, and so on. We can see that they describe the hex data specifically. And now if we go here, it's the wall header starting at 86 here, right? If we go for a root advertisement, we can see 86. We can see code 0, and also then the checksum status. And if we keep just going everywhere down here, we can see it has all the it describes the specific hex data to understand basically. And also here we have the ASCII form of the hex data basically, which is the alphabetic form of it. So the hex data can describe the whole packets here everywhere, but we can also modify it and send it as a cloned data over the Wireshark network, and it will have the same function. But what we can also do is modify the hex data, and I will show you guys many examples later as how we can actually clone many different kind of protocols. So in this clip I will show you guys the code in Python where we can actually clone the network hex packet of the Wireshark tool to send it over and replicate or also modify the hex data which it has inside to see what kind of outcome can come out of it. So for example, if we look at the code here, those are the libraries that we need for the transmission to work. That's like the target IP and port that we will send over. That's the hex data to send, and this will convert actually the hex data to the right format to send it over with the socket send hex packet. And the S connect will actually connect to the host and port number of the target, and this is the configuration of the socket. So you guys can configure as how you want. I did AF INET because it's IPv4, but there's also then a sock stream which is TCP. You guys can change it to also sock dgram or AF INET 6, which is also IPv6 IP address, and sock dgram is UDP protocol. So it depends what kind of device you target or what kind of protocol you guys copy and want to send it over. Basically, it depends on a lot of things actually. So this is just the code. So in the next clip I will show you guys actually the active form as how we will actually look at the Wireshark code, the Wireshark, let's say, network packet, and analyze it and clone it and send it over. So I'm gonna show you guys in this video is actually the Wireshark tool where I have sniffed the packets of my network and also the packets that goes out from a network to the public internet. So what I'm gonna do here is actually take this TCP protocol. You guys can see it. There's a public IP address which goes to my local, or like here at my local IP goes to some public IP address, and those are the port numbers which goes to 80, like the local address to the public port, I guess so, and the public port to the local address. So we can see it and understand it in this way. So we can actually clone it and actually do the same thing. So what we can do is actually go here, and then we will copy this as a hex stream, right? And we will go to our code back here and paste it inside here. So we have our hex format here, and we can send it over to the target. So let's try to send it over to like just send it in a normal sense as we have gotten it, like to this a public IP address, for example. So what we're gonna do is I will execute the code here. Okay, Python 3 send hex packet. What's the name again? Send clone packet. Okay. Target IP host. We will just write the IP address, which is normal like this, 76, and we write the port which seems to be port 80. So what we can do is actually open another Wireshark active listener which sniffs the network, and we can see actually if it will display like the port 80 that we will send over. So 3, 2, 1. So we actually have now cloned the packet, and we have gotten some very interesting data which I didn't guess we will get. So that's how useful actual network protocol cloning or sending over can do something interesting that we might not know it, you know. And if you guys like modify, it can happen that something interesting happens that we might not know. So that's how we can do packet cloning and sending packets over, and understanding how the target works, or understanding how we send packets over from ourselves to the target. So what we can also do is actually clone the packet to send the IPv6 IP address over. As you guys see, it has a different kind of numeric or alphabetic value compared to this IPv4 only decimal number. So what we can do is actually, let's try to copy the whole hex dump, and then let's go actually to ChatGPT to make it be writable easily. So if we like try to make this away, let's try to make this away. Just write this together without space, put it together, right? So we can paste it inside our code here. So now it's you guys need to be very careful right now and understand it. So what we need to do now is actually change the AF INET to number 6, because this IPv6 address we need to send over, right? So This means like if we go to the socket library of Python language, we can see there's different kind of ones. The default one here, IPv4, IPv6, AF Unix, AF-CAN, AF packets, and many different kind of ones that basically exist. So if you will try to send it over, we also need to write the IPv6 address basically. So if you write, for example, the target host or IP, we need to go here and we copy, let's say, the destination address, the value here, and we paste it here, hit enter, and then we will also look at the port number, which is 443 that we sent over, 443. So if we look actually now, we can send it over. We have a problem with it. Try to listen and see if it works to actually send over, not only like the code. Okay, let's try it again. Okay, 443. And as you guys see, it works, and we have sent the cloned packet in the same way as we want. So that's how we can send also over like a IPv6 IP address, like how we can actually modify it in the code. In this next clip, I will also show you guys how we can like send DNS protocols over the Wireshark network, over the Hex clone packet. So here we have the packet basically, and here's like a hex code. So I have copied it and pasted it inside here. The only difference here is that you guys see it's a IPv4 IP address, but it's a user datagram protocol or UDP protocol. So I have changed here to IPv4 and here to sock diagram. But before it was like sock stream for TCP, but we will change it to diagram for UDP, right? And we have IPv4. So now if we will, for example, send it over, right, and we make a new capture on Wireshark with DNS, you guys see like DNS like this, we will only listen to DNS request, and we try to run it, for example, and we write the DNS server, and then the target port, and the port which is used is the port 53, as you guys can see here. Now if we hit enter, we actually clone the DNS packet, and we can actually send it over the network transmission. And as you guys here, it says malformed packet for some reason, but still we could have sent the same hex data over, and well, it's a DNS protocol packet anyways in some sense. So that's how we can also send like DNS data over. You guys need to read over the protocols as how they work, that you guys can even send something over. You guys need to understand as how the Wireshark works in some sense. In this clip, I will show you guys how we can clone the ICMP version 6 packets. So version 6 means like IPv6. So it's not shows like a numerical wise IP fully, as you guys can see here. And what we're gonna do now is actually copy the hex values here. So if you, for example, want to clone this one, right? Will show you guys there will be some problem actually in sending over and receiving the same kind of data. So if you will copy this hex dump and let's paste it inside here, for example, let's delete this one behind because that's useless numerics here. So after we have removed it, we can actually copy the whole thing and then go to ChatGPT to actually make it get put together without a space, like pull it all together. So if I will try to actually put it in the hex data code here, we need to also think about changing the socket data. So first of all, it's IPv6 here, and we will make a raw packet stream. because it's not TCP protocol, it's as ICMP. And we will make socket, and then we will make IP proto. Let's make ICMP6 because that's the protocol we need. And then we will also change this to send to hex packet. And we don't need to specify port, we can leave it 0. So anyways, if we will try to execute it, you guys will see there will be some problem that the hex data cannot be read for some reason. Let me show you guys. If we try to send it over, right, to FF01, we can, sorry, let me change this real quick because you don't need a port number. Okay, let's try again. So if we try to send a destination to this one, to this address, it will say non-hexadecimal number found from hex. So what we can actually do is let's try to look at the specific protocol here, just at this protocol, and we see this section, as you guys can see here, this section here, right? It's this section of code, or like hex data. So we can try to maybe copy this and see if we can make it work the same way. Let's try to make this away. And let ChatGPT write this together and see if we can send some data over. Write this together without space. Put it together. So you guys can see we have gotten a small part of the wall protocol inside, and we can try to actually paste it inside here and see if it might work. So now if you try to send it over, let's listen to a new one, right? Okay. FF02, 1. Let me try again. Let me see if what I did was wrong. Like what was wrong. Host port. Okay. Number. Okay. So before it worked, let me try to actually see if I can copy just this one and paste it here. Of course, you need to always try out what works. Let's try a smaller part of it, like this part. Let's see if this part might work if we replace it inside here. Let's see then if it might work or not work. So as you guys can see, it works basically, and we have sent some root advertisements data, but the length is 70, as you guys can see here, right? So what we can do is actually replace and try more other hex data out and see what we can get. So again, to verify, let's do it again. Right? 3, 2, 1. We got one here again. So it's very different than the other ones. So the other ones don't work because we don't have some specific modification that we have done, right? But it can be done over time if you guys will look specifically at the protocol as how we can modify it. But anyways, as you guys can see here, there's also another code here, right? Like as you guys can see here, 3040 C, so on. Let's try it with this one. If it might work or change anything, right? Maybe something interesting will come out of it. So this also cannot be read basically. So you guys need to try out a lot of things before something might work for you. Let's try here. Okay. If anything might work. 02. And as you guys can see here, we have even a length of 72. And it shows a malformed packet because, you know, the modification didn't align to the data that we want to set over. So anyways, so in this way, we can actually modify the hex code and get some different kind of outcomes. So you guys always need to try out with different kind of numbers or code and so on until you guys find like something that can be modified in a sense that you guys would like it to be. In this clip I will show you guys how we can modify the hex data of a specific packet that we have sent. So this packet is the packet of the data. When I visit this specific website here, it will show this HTTP data, right? So what we can do specifically is actually, if you look at the Hypertext Transfer Protocol itself, HTTP, it's all the hex displayed on the right side from starting from 4.7 until down here. But if you look at the wall code, it's like the wall packet is everything, right? But we will only want to send the HTTP data specifically. So how can we, for example, change the GET request to be a POST request, for example? So what I did first was actually I made all the hex data be together here. So what this means, I made actually the hex data, because it's a lot to be able to be copied easily, but I let my code actually be the same. I don't need to change the code at all, because I just need the hex data, which is equivalent to the HTTP data packet, right? So by in that sense, I just paste it inside in the hex data. I leave the sock as an IPv4, but we can also make IPv6. And I make it as a TCP protocol as well. And I make like S connect, host, and port, and then we send the final hex packet over. So we will go to this website, and if we look exactly actually at the code here, right? You guys will see 474554. So if you will write 474554, let's check again. Yes, okay, we converted. You guys will see it's a GET request. So how can we make it, for example, from how can we make like a POST request, right? So what we can do is actually go to ASCII text to hex converter, and we can write POST, right? POST, and then convert to hex. So that's the hex data format that we have gotten. So let's try to actually copy this and check it out here in the hex input. And we'll see like post request, right? We copy this one. We will actually then go to this one. And let's actually check where it is. So here is the GET request, right? Let's check again. The GET request is about here, starting here. So what we can do is actually paste it here and make it together. So this is a basic POST request. So if we will listen to a new connection here, let's make a HTTP, and let's send actually the data over, and we should see a POST request coming. Target port 80. Okay, this doesn't work apparently because I make IPv6. Let's make IPv4 then. Okay, 80, right? So now we have gotten a POST request. You guys can see it's a POST request then. So it's not a GET, but a POST. So we have modified the hex data to send a POST request. And so we can do it with all the website requests as well. Of course, it's more easy on Burpsuite, but I just want to show what the network layer way, or like hex data way, how we can modify the HTTP packet to send a different request out, basically. So that's how it basically works. So my conclusion overall is to always like experience and try to learn yourself is how you can modify some, hex packet data and change it as however you want. So this website or this link is very important to understand and know, because that's where the socket programming is. Like there are classes where you can program all kind of different protocols dependent on on the families of the sockets. So it's important that you need to know this, because if you want to experience and try out with different protocols, you need to know how to modify the code and actually then send it out to then see what kind of reaction you get.